Good evening, I am Mr. Bell, and we're in Hillsborough High School, the Hillsborough High School Technology Laboratory, or Technology Center as we like to call it. Putting some final touches on some projects that are headed to nationals next Wednesday. Seems kind of strange to be in on a summer evening, but we are, like I said, putting final touches on some projects, making sure they fit in luggage bags to board an airplane next Wednesday. And what this is about is these students are participating in the Technology Student Association. It is a career and technical student organization, much like FFA, FBLA, FCCLA. Only this has the STEM background, science, technology, engineering, and math. They have chosen projects of the many or the numerous projects and events that TSA sponsors. I believe there are about 32, 34 events. But they chose their events last September, and they began planning and designing, and then they began construction. Some projects through classes, such as a Dragster that we use as an engineering design project in our CAD, or computer-aided design and drafting class. Or they're using structural knowledge and CAD background for building structures. We also have robotics and use other classes for support there. But the projects start in September with, like I said, design and planning, then construction begins, and throughout the year they test and iterate, and it culminates at our state TSA conference, which was held at Webster Conference Center in Salina this last March. I believe our structural design and engineering team placed second, right? And in Dragster Design, Jacob Denholm placed first, and Jacob Isaac placed second. So that qualifies them both locally and nationally to advance to the national level. At National TSA, which will be held in Orlando this year, we expect up to 7,000 students from across the United States. The guys were reminding me we had the Ukraine, students from the Ukraine last year participate. We've had Germany participating for about 4 years now, and also Turkey. Turkey has also been sending some students over. So it's growing by leaps and bounds, and I believe it's because of the STEM push from our government and our society. So what else can I tell you? I think I'd like to turn it over to these guys and let them tell you about their projects that they know so well about. John, Nathan, you want to tell us about structural design and engineering?
All right, this is structural design and engineering. So what we do is we build a structure out of, well, this year it's balsa wood, sometimes it's basswood, and it gets put under a tester, and the goal is to hold as much as you can with using the least amount of materials as possible. So basically it sits in the tester sort of like this, with the two beams underneath, and then this block is pushed down on the structure until it breaks, and then the goal is for it to obviously hold as much and weigh the least of any structure, so you're graded on an efficiency score rather than just how much it holds.
When we first start off, we have to come up with a drawing and then show the judges and stuff like that, and then we get the kind of how much wood we think we're going to use, and then we just start cutting it and gluing it together to get like these separate beams and stuff like you see there. And the glue we use is a CA glue. It's a very quick drying glue and it's very strong. We also use this special cutting board to get like different angles that we need, or to make sure that the cut doesn't come out wrong or anything like that.
So this year's problem is the crane girder. So the goal is you have these two separate triangular beams that slide in and out of this holder piece that allows them to move around, because the idea is for it's the type of crane that would be used to build a bridge so that it can reach out. So then it's tested randomly at lengths of 8 to 12 inch spans. So the blocks that it would be sitting on range from 8 inches apart to 12 inches apart. So that is a big part of designing it, making sure that it can work with all of those spans, because it's a big part of how much it can hold. So our structure here from state held about 76 pounds. That was 20 some grams. The whole structure weighed 20 some grams and held 76 pounds. This structure here I think will hold closer to 100, and it weighs 30 some grams. I'm not quite sure exactly how much it weighs, but yeah, this one should hold more. So yeah, a couple years ago we had a structure hold up to 455 pounds, and it weighed in the 20s. But that was a different problem, so we were able to make it stronger.
In the beginning, up to, well, I guess you'd say back to 2007, we would develop a strategy or a design, construct the design, and then test it with our tester, establish our results, and then go back to the drawing board and redesign, iterate again and again until we had the best solution. John, what are we using now?
So during my freshman year, I learned how to use Autodesk Inventor, and so I stretched out a little bit more and taught myself how to use the stress analysis feature on there. So now I can design and build the structures virtually and then test them virtually to see not necessarily how much they'll hold because materials and stuff online don't work, but where the weakest points would be and figuring out how to disperse the stress as even as possible. So that's a big step that I've made that's led me to 2 state championships and 2 second places at state.
We've also had engineers from local businesses come in and coach us, help us learn more about, do I want to say moments of inertia? No, that's probably the wrong physics.
Yeah, the moments of inertia is a big key of the structures. That's one thing that I learned myself, though, in POE class.
Do you remember when Tom Kaufman came in?
Yeah, he talked more about angles and the best places to disperse the stress. So yeah, it was big about just different ideas that, you know, I know where the stress might be. Then he comes in with ideas of saying, well, this is how we can disperse that stress instead of me trying to figure that out.
What are the pins that you have down here, John?
So every one of these pins, the red ones represent state championships that I've, or it's not championships, but finalists that I've been part of, and then the green pins are national finalists. So the first 2 were my freshman year, and then these 4 were my sophomore year, as well as this national finalist. Then last year was these 2 red and these 2 green. So the 2 events I placed at state and actually won at state. We went on to nationals and placed in those. And then the 3 final red pins are from state this year. So I'm looking to follow that up with a couple more national finalist pins.
So who gets or who receives a finalist pin at nationals?
At nationals, the top 10 receive a pin, but then the top 3 get a trophy along with it, and the trophy height depends on if you get first, second, or third. But it's, yeah, just the top 10 get a pin, and then at state, the top 5, I believe, get a pin, and the top 3 get a plaque that has their place and everything for their event.
So first, seconds, and thirds are not golds, silvers, and bronzes. There are not groups. There will be one team in the nation that is number 1. There will be one that's number 2, one that's number 3, one that's number 4, not a group of ones. So when these guys, if and when these guys place first, second, or third, they will be the ones. So that makes it very, very special. Thanks, guys. Jacob, tell us about how we came up with a dragster. And you can rely upon your CAD class. I'll try to add some things as we go along.
Well, we started out in CAD class with Autodesk. Yeah, Autodesk.
AutoCAD.
Yeah, AutoCAD. That allowed us to just 2D sketch a design that we thought might work. And then after we finished that design, we imported that design into SolidWorks 3D that we put on a blank Dragster blank that was virtually modeled, and allowed us to have a 3D design that we could then analyze using FlowWorks and SolidWorks, which is an add-on that you can just use in SolidWorks, and allows you to analyze the aerodynamics of the design, and it gives you values that represent your drag and your lift, like that. And then it also, we use surface plots to help visualize where the drag was coming from. So like on a plot that we used, a red would be like high yeah, high drag, and a light blue would be low drag. And so then we would go back and change the design to try to improve the aerodynamics of the dragster and get the best design that we could, which is where I made it at State. The design has not really changed, just kind of the implementation. So we added the decals. Like I painted these decals on the top of the dragster and on the side of the dragster, because decals play a big part in scoring. That's one of the categories is looks.
Can I give you some more credit? Those aren't decals. They look like decals.
Yeah.
What Jacob did is design that script or design this text using software, and then he used a laser engraving machine to cut that out of what we call spray masking material, and then he laid the spray masking material onto the dragster, then airbrushed. I should let now I got you going. You can finish it out. But a decal you can purchase and just stick on. It's a sticker. These are not stickers. If you touch that car, you can't feel those graphics because they're underneath. They're inside of the paint. Go ahead.
Yeah, with an airbrush, we lasered out a negative of the decal that I wanted to put on, that I wanted to airbrush on. And then I went into our finish room that we have in the lab and airbrushed that on using the paint, which probably took 15 minutes per coat. You know, probably. And yeah, that was how that happened.
Did we just stop with the airbrush and
No,
black
and
paint?
after the airbrush dried, Mr. Bell helped me mix up a custom clear coat that then was sprayed on over it to seal everything and give it kind of that shiny look.
So why did you have it up on that scale?
In the specifications for the dragster, you have to come in above a certain mass, and this year that mass is 35 grams. And there's a whole list of different specs that you have to meet in order to be able to compete, and that mass is one of them. So you have to be over 35 grams, but you want to be as close to 35 grams as possible because a lighter car will go faster. Does kind of make sense. And right now it is at 35.62 grams, and so that's a little more than I want to be at right now, but I'm not going to adjust it right now because humidity and things will make it change a little bit. There was a lot of work that went into designing the body of it, and in there I also, when I was thinking how can I improve the aerodynamics of the body of the dragster, rather than drastically changing the body, which would require redistribution of mass, I thought, well, normally the wheels will have a solid tread on the front face here, but I thought, well, since that's causing a lot of drag, why not just have like two rudders here and cut out that centerpiece of tread? So when I modeled that in SolidWorks, and then after that I reanalyzed it, and it dropped the drag by quite a big margin. And so we started out, since it's really not that easy to machine out of the plastic, the acetyl-copolymer that we use, which is what the front wheels are made out of. We will machine the wheels using the CNC mill and lathe that we have here in the lab. And since we don't really have the equipment to machine out the centers of these wheels, we decided to try to use the 3D printer that we got this year. It's a stereoscopic 3D printer, and we used a photopolymer that we can dry using UV light to try to make these wheels, since it was a lot easier to print these wheels than it was to machine them. But this plastic is too brittle for racing. When the dragster would decelerate at the end of the track via towels, it would just snap the wheels like you see here. So then we came in here Mr. Bell and I went back to work, and Mr. Bell made a custom tool that we could use with the lathe to cut out the center portion of the wheel so we can keep the design with just a little bit more mass, but a lot better strength and a lot more stable properties of plastic.
How many times do you expect to have to race that? If you're talking about how the wheels are possibly going to be brittle and break and having redesigned them so they're stronger, how many times is this going to have to run? Do you know?
More than once.
So it's important that they're strong.
Yeah. At state, we ran each dragster ran twice, once down each lane in the track. Since it's a 2-lane track, dragsters race side by side to each other. And at state, it's run each dragster in one lane, in each lane, and then the times are averaged to give an average time, and that's what the scores are based off of. But they run it a little bit different at nationals. At nationals, it's a single elimination. So if your dragster does not win, it's out, and you don't race in both lanes. So, but if you move on, it's basically kind of like a tournament bracket. You race a car, and if you beat it, you move on, race again, and then if you beat it, race again until you get to the championship or you lose.
Do you remember your times, or your average time at state?
It was under 1 second.
Okay.
So, down a 60-foot track.
What time did you run with that latest design?
It was under 0.8 seconds. Wait, under 0.9 seconds.
Okay. So, I thought I'd bring this out. This is Jacob Isaac's dragster, the other student who will be racing in the same event, and he named his car the Patriot. He had no graphics, so when we came back from state, both Jacob, if you will, I inspired to add some graphics to go on to the next level of competition, because it is a much greater level of competition. So they worked up the ideas for the graphics. Jacob Isaac had some background in doing this before. He's been in that event once before, so he didn't require as much assistance. Jacob Denholm, however, is a freshman and it's the first time, so we worked a little bit closer together. But what are some other quick, off the top of your head, specifications? You might even be able to use your drawing. What's the drawing about? Why do we have that drawing?
That's another judging category. It's like,
Hold that up.
it is, well, I don't remember off the top of my head how much of the competition, like how many points the drawing is, but it's a fairly large margin. So if you don't have a drawing, which it's not 100% required, but if you don't have the drawing, you shouldn't really expect to win too much, because those that have a good drawing will probably pull ahead even if their dragster isn't the fastest. Like if you have a faster dragster, but not by that much, the person that has the drawing will probably pull ahead.
What else are you judged on? Do you remember if there's something special at the end of the event?
Yeah, there is a interview if you make finals in the event, and that is introduced this year, isn't it? Yeah, it's just introduced this year, and it's called LEAP, which is basically kind of a leadership type thing, where you are trying to demonstrate your knowledge of leadership and knowledge about your event. So.
Sounds great. Can you pop off a couple of specifications?
Well, there is a diameter of each wheel that has to be at 30 millimeters diameter to be in spec, and there's a maximum diameter, but I don't remember it.
Okay. So, lots of specifications.
Yeah. There's like a 5-page packet of specifications.
And any one of those specifications can cause him to disqualify. If his dragster is a millimeter too long, it disqualifies. If the wheels are a millimeter too small in diameter, too wide, what else? If they've sanded too close to the power plant housing. And this event isn't the only one with specifications. The structure, again, has to be within tolerances. It's engineering. It's engineering. It has to be close. You know.
Great Plains Federal Credit Union in Hillsboro. Now's the time to see them for that vehicle or home improvement loan. You'll like their competitive rates. Member NCUA. Cottonwood Law Group. Innovative practice, practical solutions. Find Josh and Courtney Boehm with Cottonwood Law Group at 107 East Grand in downtown Hillsboro.
Around here, we believe in local values like hard work, family time, or a fair price on reliable internet from a local company. That's why Eagle Communications delivers great local values, like a range of internet options to fit your family's needs. Fast and consistent enough to power everyone's devices at once. All at reasonable prices we're proud to offer our friends and neighbors. Ready for better internet? Give us a call or visit eaglecom.net and discover our local values today.
Here we've kind of collected the evidence, or when we say the results of our trips to nationals. Students have to qualify both locally and with the national TSA, state TSA to go to nationals. But here are some of the results we've had throughout the years. First trip to nationals with actually some winnings was in 2007, and to keep some things in perspective, we had a team that placed third in that structural design and engineering competition, and we had a 7th place in Dragster. Moving on, here's Dragster, 6th place, structural design or structural engineering, 4th place. Just to kind of see the history. I don't know really how this happened. It's the kids want to do it. We study it. It's a problem-solving activity. I argue it's no real different than figuring out what size of cabinet somebody wants and building it to their specifications and getting it to work for them. Only the judging's a little bit more broad spread. But anyhow, throughout the years you can see the structural design and engineering and dragster design is a favorite of these students. Maybe I guess you could say we've specialized there. But we have, I believe, if my count is correct, 9 top 10 dragsters in the past 11 years. So that's pretty cool. And they can be viewed, these students and these dragsters can be viewed on scienceofspeed.com, and that's hyphenated between each word, science-of-speed.com. And that is produced by Pittsco out of Pittsburgh, Kansas. Pittsco produces a lot of dragster parts. They produce balsa for structures. They're just a great supplier for STEM education and technology education. So it's been fun. It's been really fun. This will be this year's. Kind of a little walk down the hall of reminiscence. Here's some trophies that we've gained over those years. And because we're talking about structural design and engineering, we have 2 structures in here. One that was used at the state conference or state level that weighed 16.12 grams and held 170 pounds. And at nationals, the same problem, which they have to build these on site. They're given 2.5 hours and materials, and they have to build that structure. The structure sits for 24 hours, then they test it. But they have to build it on site, so they don't get to walk in with plans other than what's in their head. Then they scratch it out on paper or draw it out on paper like Nathan was saying. Then they build the project on site. This one weighed 21.39 grams and held 190 pounds. Which earned them a 3rd place in the nation in 2007. You can see a plane here. Oftentimes students want to build a rise off of ground aircraft or airplane, and we have a 2nd place trophy with that one. Prior to that, we've had 3rds and 1sts. Here's another 2nd in flight. Here's a 1st in structural design and engineering, or structural engineering, and a 2nd in structural engineering. So it's been a lot of fun. Kids building projects, doing some things they like to do. I really like to see them utilizing knowledge they've gained from the classroom, skills they've gained from the classroom, and apply it to a project and take it out of this building, take it out of this state, and show people what they've learned and what they can do.
Norrell Farms Bakery, downtown Hillsboro. Bread from our home to yours. Featuring fresh baked breads and delicious baked goods. Watch for manager specials and frequent specials posted in the bakery. Hillsboro True Value Hardware, downtown Hillsboro. One stop for paint, tools, power lawn equipment, lawn chemicals, Crosley appliances, and everything in between, where behind every project is a true value.
Our employee owners make it happen. We're part of your community, and we take pride in delivering excellent customer service. If you ever have a question, give us a call. We're here to help. Eagle Communications, our community connected.